Real-time folks join and we can have a quick intro. Hi, this is Ankit. I'm from SigNoz team, look after growth and community here. Like if you want to go ahead.
Yeah.
Hi, I'm Doug Ramirez. I'm a SigNoz fan. I'm a software architect and been writing software for a really long time.
Good to have you here.
Yeah, likewise. I'm glad to be here. We've got a really big winter storm passing through here right now, so hopefully nothing's going to interrupt my ISP and my access to the public internet.
Where are you joining in from, Doug?
Central Virginia. I live in a small town called Crozet, Virginia, which is right in the foothills of the Blue Ridge Mountains. They're right outside my back door, and snowing pretty hard.
Oh, take care.
It's really pretty.
Cool, Chitransh. I think
We can start.
give you a brief overview of the call. Let's start with that.
Yeah, sure. So hi everyone. Thank you so much for joining. I'm Chitransh, and I'm part of the growth team at SigNoz, and I'm also one of the maintainers of SigNoz. The general format that we follow we are trying something new this time in the community call. We have Doug with us, who has used SigNoz. We had a really interesting conversation around how he created that. Like he's going to do a really cool distributed tracing project that he worked on, and how he used SigNoz for it. So yeah, really excited for this. So Doug is going to do a demo for us about distributed tracing using OpenTelemetry and SigNoz. Once you're done with the demo, we have a Q&A. So we follow a lean coffee format. I'll share a link of a board where you can just put down your questions, anything that you have around SigNoz or OpenTelemetry, and you can just put down those questions there, and we'll try to answer as many of them as possible. Yeah, if you have any kind of feature request or feedback for us, you can put it there itself. So cool, Doug. Let's start off. If you want, again, like I think a lot more people have joined in. So if you want, you can just give a brief intro about you, how you got to know about SigNoz, and like what are you going to do with demo today?
Sure. Good morning, good afternoon, good evening, everyone. I'm Doug Ramirez. I'm a software architect. I've been writing software for a really long time. And one of the things that I've spent a lot of time on in the last few years is observability. And what I really like about observability is that I think this probably resonates with a lot of you. The first time you start writing software and you get to see your program run, it's really exciting, right? You get to see the statements you've created, you get to see some output, and it's just really exciting. I think we all had that experience the first time we started writing code. Well, these days, a lot of the code that we write is, running on services, running as services, running in the cloud, and sometimes you don't actually get to see what's happening with your code. And what I really like about observability is it kind of brings me back, at least, to the early days of writing software, where I get to see my code doing something. And for me, a lot of the code that I've written in the last several decades is a lot of back-end services, a lot of systems integration, data platforms, things like that. So, for me, observability is really important because it makes me happy as a developer, but it's also what I consider one of the pillars of any architecture characteristic of an application. And so with the work that I've been doing around observability, I've been able to spend some time with the OpenTelemetry group, the CNCF project. I've been able to talk to them about observability and do some presentations around distributed tracing in particular. And during the time that I've done that, I've been on some podcasts and been able to talk about observability. And as I've worked on this reference implementation that I'll share with you all here in a moment, one of the things that I discovered was SigNoz, probably about a year or so ago. And what I really liked about SigNoz was before I was trying to build my own observability stack and, trying to use Elastic and Loki and Prometheus and all of these things, what I found with SigNoz is that it was really easy for me to use their packaged up version of it so that I could run it in a container locally. Personally, I really like this idea of like writing code on an airplane or in a cabin somewhere. And so being able to write software using containers and have my observability platform running next to me locally is really, really powerful. And using SigNoz, for me at least, is super, super easy. I really like the interface. It supports all three signals for observability: logs, metrics, and traces. And I'm just a real big fan of it. And I'm really glad to be able to kind of show you this reference implementation and show you distributed tracing in particular through the lens of SigNoz. So I'm going to go ahead and share my screen if that's okay.
Yeah. Are you able to share your screen?
Yeah, I need to do that thing with, sorry, it's the system and audio recording thing in Mac OS. I might need to drop off the call and come back in. Yeah, I'll be right back. Sorry. I'm sure we've all seen this thing before. Give me 1 second.
Welcome everyone else. Great to see you on the call. So Doug is currently giving a demo of how he has implemented distributed tracing using SigNoz.
Yeah, I mean it's a really really interesting demo. Like he's going to also demo a couple of trace features that we launched recently in our launch week. Yeah, I mean for anyone who is new to observability or OpenTelemetry, I think this demo can be a good resource to learn more about distributed tracing. And I think, like Doug mentioned, right, we kind of use microservices a lot these days. I think almost all the major systems work on microservice architecture. So again, distributed tracing kind of becomes a really critical thing apart from logs. So yeah, we have Doug back.
Okay. Yeah, I'm back. Okay, let me share my screen now. Allow.
Is it allowing you now? Oh, nice.
Okay. So hopefully you can see my desktop here.
Yes.
All right. So I have this really simple repo that has all the code that I'll be showing you today. And this reference implementation is designed to try to capture the concept around distributed tracing using a very simple set of services written in Python using the Fast API framework. And the purpose of this reference implementation is really to try to highlight with as few lines of code what distributed tracing is and why it's important. So distributed tracing, the way that I like to think about distributed tracing is back in the old days when I was writing code in monoliths, debugging was really simple because you could trace a transaction like placing an order, reserving inventory, processing a credit card transaction, taking the inventory and allocating it to that order and applying the payment to the order. You could debug all of that. You could step through every bit of code and see all of that code running in the context of a transaction, usually within one process. as things have evolved and for reasons, microservices have become popular, that kind of tracing is really hard to do. It's really hard to see your code executing when it's spanning multiple processes, multiple services, sometimes multiple clouds. And what distributed tracing does is it's a software design pattern that allows you to observe how a transaction traverses many, many services. And what it does is it takes the concept of tracing, which you may be familiar with already within a service, and it uses something called context propagation so that each service that runs knows a little bit about the service that's calling it, and it builds up a chain of calls so that you can see the traces and spans within each service all tied together. And there's a concept of log correlation, which takes all the logs that any of those services may have been emitting, and it tags them all together so that with the trace ID or the trace parent, you can see all of the call executions in your call chain, and you can see all the logs from all those services all tied together. And a really great way to observe those things is through an APM like SigNoz. So, distributed tracing is really, really important these days, being in the cloud with microservices. And, I would say that it's really impossible to design, run, and operate a set of microservices without observability and without a tool like SigNoz. Impossible might be a strong statement. I would say it's impractical. It's very difficult to do. And I'm going to walk you through a demo that's probably going to be familiar to all of us about what it's like not to have observability and not to have something like SigNoz, and then what it's like to have those things in place. This repo, I invite everybody to go look at it. I'll share the link afterwards if you weren't able to capture it. But it has some information that kind of breaks down the concepts around distributed tracing, context propagation, what a span is, what a trace is. The way that I like to think about spans is they're kind of like spans of a bridge. And if you have a route that traverses several bridges, your trace is your entire route, and the spans are the individual segments of your route. And within the context of a transaction that traverses maybe an order service, an inventory service, a payment service, the trace is the collection of spans and the execution paths across all those different services, all tied together with a trace parent. And there's some links in here that will take you to some other information around, recommendations from the W3C. I like to put these in here just so that people know that this isn't something that Doug's making up. These are actual real concepts that, that I'm standing on the shoulders of the giants before me who've thought about these things. And then also break down some of the semantics around what is a trace parent, what is trace state, things like that. So I also have a link in here to how to set up the SigNoz in your local environment if you want to do that. I find it really handy. Again, I love the idea of writing code on a plane, and having SigNoz running locally is just brilliant. Okay, so let me jump into the demo real quick. This is hopefully something that is familiar. So imagine I have a set of microservices, and let's say I've got a mobile app or a web app that has a back end for a front end. And in this case, I just have a client application that's going to act like my back end for the front end, and it's going to call into this service, a band service. So this is kind of like the internet, instead of the internet movie database, IMDb, this would be like the internet bands database. So just a service that has information about bands, and then reviews of the bands. And the reviews platform is another third-party platform that is tied into this whole thing. So this is the client, and I'm going to run my client, and it's going to make a call to the band service to get some information about band and the reviews for the bands. And this call took 6 seconds, which is a really long time. And so imagine you're in an environment where you're working and, I'm working on the client. I say, hey, team that runs the band service, I'm making calls to your service and these calls are taking a really, really long time. Like, can you tell me what's going on? And, I think we've all experienced that situation where like somebody slacks you and says, hey, I'm making a call to your service and it's taking a long time. What's going on? And, the next thing people do is you kind of like start SSHing into boxes and repping logs and trying to figure out what's going on. It's really hard to do. And that's why I say that it's hard to design, run, and operate microservices without observability, without an APM like SigNoz. It's just really impractical. It just doesn't work very well. So in this case, I'm going to contact the the band's team and say, hey, something's going on here. And if I'm on the band's team, I'm going to say, I really don't feel like jumping onto some boxes and grabbing logs right now, but our service implements distributed tracing. So if you make a call to our service, check the headers of the response and you'll see a trace ID. And if you give me that trace ID, then I can debug this really quickly. So in this case, I'm going to go ahead and add do what the band's serve team said and put this little bit of code in here to capture the header that's coming back from the service that I'm calling. So now when the client calls the band service, I'm going to see a trace ID. And I'm going to cheat a little bit here and go ahead and so that I don't have to search in SigNoz for the trace ID. I'm just going to put a link right into the trace ID into my code here. So now if I'm on the might just take a minute to propagate here. Things are running asynchronously, so it might take a moment. So if I'm on the band's team and somebody calls and says, hey, your service is running slow, if I can give them a trace, what time is it? Yeah. So I've got the right trace ID. Okay, so this is the right trace ID. So now I'm in SigNoz and I've got a trace ID. So the client called my service, the band service, and said, hey, your service is running slow. I said to them, hey, check the header for this trace ID so that I can help you more quickly. They gave me that trace ID, which is really helpful. And now I can see a flame graph. So here's all of the different calls that were made in that call chain. So somebody called into the band service. The band service called an internal function to get reviews. It called another service, the review service, that called a function internally. And the collection of all those calls is really long, right? You see, it took 8.87 seconds, which is a long time. So what I want to do is say to the person, hey, okay, now that now that you're able to, now that I'm able to see what's going on, I do see that there's a problem here. Like, this is taking too long. So what I want to do is say, okay, hang on one second. Let me go and put everything into debug mode on my end. So I'm going to go into my band service. And I know we're looking at some code here. And normally I would have a bit more time to kind of explain what's happening in the code. But if you just follow me for a moment, and I'm basically going to set each of these services, the band service and the review service, into debug mode. And now that the caller understands that, hey, when you call me, you're going to get this trace ID back in your header that allows me to see what's going on more quickly. And I'm going to ask them to call the service again so that I can see a little bit more of information, because now I've set the logging to debug mode. So now when the client calls back into the service, I haven't really fixed anything or done anything yet. It's still pretty slow. It's 6 seconds. That's way too long. So if I go back into this trace, I'm not sure why that's not working. Oh, here we go. Okay. So now I can see, yeah, it's still taking quite a long time. It's about 6 seconds. One of the things that is really nice about OpenTelemetry, and I mentioned log correlation. Log correlation essentially creates a relationship or relation between all the logs that are being emitted by your service, and it's associated with a trace. So at this point now, this trace that has these 4 different spans in it, I can go and immediately see all the logs related to this, regardless of which service is emitting the log. So now I can see a bunch of log statements here for both the ban service and the review service, different microservices, different processes. It could even be on different clouds. But now I can see all of them together. So I can see the entirety of all the log statements running across all of these different services. And that's what log correlation is. And now immediately, as the person on the bans team, I can say, oh, I see some debugging stuff's turned on. Let me go back into my services and see what's going on. So if I go back into the ban service, I can see that we do have some debugging turned on here. And what is the debugging doing? It's just sleeping. Oops, sorry about that. Let me turn off that. I saw that also happening on the review side as well. Yeah, it's just sleeping for a random time. I don't know why. Let me turn off this debugging stuff. It shouldn't have been there. And VS Code's doing something strange. Okay, my services are restarting. And what I'm also going to say to the caller, the client, is say, hey, you can also implement distributed tracing on your end. So you should change your service to start a trace on your end. That way we can see not only what the ban service and the review service is doing, but we can also see what the client is doing. So with a little bit of code here, I'm going to change the client, which could be like a back end for a front end or something like that. So it's going to start its own trace. And when it starts its trace, it's going to propagate that context using OpenTelemetry and the SDKs that are there. So now we're going to see a call chain that includes not just the review service and the ban service and the review service, but we're going to see everything starting from the client, calling the ban service, calling the review service, and all the way back out again. So we should see the entirety of all these calls. And hopefully, since I've been able to fix the problem, which are these kind of rogue debug sleeps, this should all kind of return within a few, 10, 12, 50 milliseconds. And it did. So that was a lot faster than it was before. And so if we go back into, and I can also say to the caller, I can say, hey, now that you understand distributed tracing, log correlation, and you're able to start to trace on your end, you don't need to Slack me anymore about performance issues. You can just hop right into SigNoz and you can see this yourself. And so now if I'm the caller who's building, let's say, the back end for the front end, I'm able to get into SigNoz, the APM, and go, oh, boy, now I can see here's me calling you. Here's you receiving my call. Here's you calling the review service. Here's the review service doing its thing, and then getting, let's say, data from its local database, its local data store. And things are working much better. And if I'm the caller building the back end for front end, now I can see all the log statements associated with my service logging, the ban service logging, and the review service logging, and I can see all of those logs correlated and stitched together because of log correlation, because of context propagation, because of distributed tracing. So, I know that was super fast, running through a whole bunch of stuff. There's some code that we were looking at. There's a lot of concepts here. I think that the main point that I want to try to drive home with this demo is that we're all familiar with this idea of like somebody calling you or Slacking you and saying, hey, I called you, something doesn't seem right. And, it's really hard to debug those kind of issues. And for me as a developer, if I'm building the backend for front end and I'm calling all those microservices, this is what I want to have. And if I'm a member of those other teams that are building those services, this is what I want the other teams around me to have, because I don't want people to guess and I don't want people to slack and I don't want people jumping on boxes to grep logs. I want to give people information at their fingertips to be able to properly observe their code executing in a runtime environment. So, if you bring together, OpenTelemetry, this concept of distributed tracing, and a tool like SigNoz, hopefully you can see that this just massively accelerates the time at which you can build things, debug, and on top of that, I think it really just creates a really wonderful developer experience. I know that this is the type of environment that I want to write code in. I've written code in those other environments, and it's really, really frustrating. So, that was fast and that was a lot. What questions do you have? What comments do you have? I'd love to hear from some of the SigNoz folks if there's things that you'd like to kind of point out on the user interface here, like how to navigate some of these observability signals.
Yeah, I mean, really good demo, Doug. Um, like the whole concept of a service and a client was, I think it's really realistic to what actually people might face in a production environment. So yeah, I mean, the
So
one
one
thing
of the,
that, yeah, sure.
yeah, so one of the new things that we have shipped with this new trace detail page, folks, is that you can load as many spans as you want in this page. So earlier we had some limit on the number of spans that could be loaded, but now it's like even if it's like 1 million spans, you can load it. That comes in handy for things like messaging queues or when there are background processes. And of course, if there are like so many spans, it's very hard to navigate through them. So we have also introduced a search filter that is above this spans where you can search based on attributes. Vikrant, if you want to correct me somewhere.
No, you absolutely explained it correct. So this search comes very handy when the structure becomes such huge that it's visually impossible for you to grasp what's happening. So you can quickly filter out on attributes, like maybe you're interested in some span containing any particular attribute. So you can jump around very quickly. It is a very nice intuitive UI where you search on it and it'll give you a counter of you are currently being an X span out of the maybe Y spans which were part of that search criteria. So it comes very handy with that respect. And yeah, I think Doug, you mentioned a lot of things very nicely. Like you see here, you can see 1 out of 2 on the right hand side of it.
Oh yeah.
Yeah, so from here you can navigate to the second span, you can navigate to the first span, you can see the highlighter moving up and down across parallelly as well. So this comes very huge trace. So that is exciting, and I think Doug, you already used to navigate the waterfall model using flame graph. You navigated to the below waterfall model using the frame graph. So that is a very nice handy feature which comes in play. And personally, one very unique thing which I would like to point out for the folks is if you see at any point of time, your waterfall and flame graph are in sync with respect to the timelines. The timeline for that 0 millisecond to 198 millisecond is in sync on both the above and the below graph. And you can rearrange this as well. If you go to that divider, you can increase and decrease the size of your left area as well. Maybe you have something very huge on the left side which you want to read, or you want to increase more area for your timelines. You can dynamically adjust this section as well. And a flame graph gives you a nice overview of the entire thing that has been happening, while you can dig down into the details into the waterfall model. So these are some of the exciting features that we built, and we would love to hear your feedback around it, or any other use case that you guys have solved using it, and any other questions do you have around it.
Cool, Doug. I mean, Jitansh, I think now we can move
Yeah.
ahead for the Q&A. Thanks a lot for doing this, Doug. It was great. This was our first time, inviting a community member to demo in our community call, and thanks for taking up that challenge and doing such a nice job at it.
I'm glad to help. And for anybody on the call, if you are able to check out the repo and you have any feedback, please let me know. If there's anybody that needs help getting SigNoz running up and running locally with Docker, let me know. I personally love the idea of being able to run my APM locally. Obviously, SigNoz has a cloud version of it that you probably should be using for production. But if you're just developing and you want to have that, running locally right next to you, having SigNoz right on your laptop or your local development environment is just wonderful.
Cool, thanks. Doug, can you share that repo link and maybe some place where people can reach out to you in the chat? Yeah, Chitansh, can you run through the lean coffee format now?
Yeah. So,
İnsan 15'te mi girdin? 15'te mi girdin?
Just this.
Sana veriyorum 15'te.
Yeah, Chitansh, go ahead.
So, I'm sharing a link to Agile Coffee Board. Let me share my screen and just show you one. Cool. So, this is the coffee board that we use. If you have any question, want to discuss something about SigNoz or OpenTelemetry, something that Doug explained, you can just put down the questions here itself. You can use this plus button to create a new item. Just put down the question. And we also have a thumbs up feature. If you want some question to be answered first, you can just do a thumbs up and we'll try to pick that question first. So let's take 2-3 minutes to put down any questions that you have, and we can start working on answering these questions.
I think we can start taking the questions also, as we don't have much time left.
Yeah. So we have one question for people who start with SigNoz locally via Docker. What's the recommended path to moving to the hosted version when ready for production use cases? The person asking this question, can you share more detail on this?
That was actually me.
Yes. So yeah, can you elaborate a bit more?
Yeah. So if I'm starting off building something new and I've got SigNoz running locally, maybe I'm building some dashboards, maybe some I've got some filters and queries that I've built up, and I'm starting to kind of dial in my what I want to specifically look at, using SigNoz to observe my software. If I then decide that I want to move to the hosted version and then have that ready for production, what does that migration process look like? I don't want to recreate all my dashboards and filters and things like that if possible. I'd like to just kind of shove everything over to the hosted version of it and have it all kind of auto-magically appear.
So by hosted version, Doug, do you mean the SigNoz Cloud version? SigNoz Cloud, right?
Yes.
Okay. Vishal, do we have any advice here?
I don't think Vishal, do you want to weigh in?
If you want to weigh in, you can weigh in as well.
Okay, so yeah, Doug, right now the recommended way is for you to just hand over some stuff that we ask for so that we can do the migration for you. We are looking to ease that process so that it's more of a self-serve way wherein you can do it yourself. But right now, there is no other way other than to reach out to us and let us help you with that migration.
Okay.
It's not very difficult for you right now. It's actually very easy in the sense we will share you some commands so that you can share your SQLite DB you can say the metadata, majorly the metadata which has all the information of your alerts, dashboards, saved views, and other like user preferences and all, so that it's easy migration for you. But that also depends on the version you're running of SigNoz. So some of our users who have migrated, like we're running, you can say a year-old version. So that was a bit challenging for us, but yeah, that's not very seamless right now. Like you have to share us, and then we'll get back to you maybe in a few days, and you will be up and ready.
Okay. Perfect. Okay.
Yeah, you were
Thank you.
asking something, I guess. Before I said interrupted.
No, that's I'm glad to hear that there's a path to migrating the settings, and super excited to see what happens when the self-serve feature is out. So thank you.
Cool. So, next question we have: how should we link parent and child trace IDs to get a better understanding of the flow of data? So, the person asking this question, can you elaborate this a bit more?
Oh, yeah, that would be me.
Yeah,
So having two trace IDs makes a lot of sense. But where I'm struggling with is if I create a parent trace ID, right? And for example, the way you were showing it, different actions have different trace IDs. So I'm having trouble linking the parent trace ID with the child trace ID. I'm not sure if that's clear or if you need more information.
We'll tie everything together for you. And if that I built, one of the things that I did in that reference implementation is that there's the creation of the traces is all very, very explicit. There's another way to actually use the OpenTelemetry SDKs. It's called auto instrumentation. And for languages like Python, the SDKs are really smart. Like they'll do a lot of work for you. So there's an alternative way of building these services where you kind of let OpenTelemetry do the auto instrumentation, and it will it'll do the same things that you'll see the services doing very explicitly. So if you look at, let's say, the code for the bands service, that route that for the get bands, if you look at the code there, you'll see some things where it's calling into the OpenTelemetry SDK to it's like the trace context map propagator. Let me sure I get that right. That essentially is telling the OpenTelemetry SDK to look at the context for the call that's coming in. If it sees a trace parent in the header, it will tease that out. And then when you start your new trace with a span, the SDK will stitch those two things together, if that makes sense. So there's a lot of magic that's happening with the SDKs, which is awesome. And if you dig into the documentation that OpenTelemetry provides, it'll explain it a bit better. But the short answer is the auto instrumentation will do it for you. If you do it manually and explicitly, like you see in the reference implementation I built, you'll get the same effect. But it's mainly around that. Let me make sure I get the right term here. It's that it's the trace context text map propagator function does the work of looking and inspecting the call that's coming in, looking at the header, finding that trace parent, dissecting that trace parent to pull out the trace ID and span ID of the caller, and then it'll marry it with the trace that you just created. And then when those signals get sent away from your application and land in SigNoz, SigNoz will then display all these things together for you. So lots of wonderful magic that make observing your software really easy.
Just adding on to that, so there can be two cases here as well. Let's say you mentioned two trace IDs, a parent and a child. So they can be very tightly coupled. Then it makes sense to have all of them in a single trace. But let's say they are very loosely coupled. So one other trace is a side effect or is another sub effect of the first trace. You have another very nice feature in OpenTelemetry called span links. So in that, you can link the second trace in a loosely coupled way with the first trace. So you'll know that this particular trace happened, but on a side effect, it generated this another trace as well. So span links helps you with that. And if it's a very tightly coupled, everything comes in a single trace. So span links is something that we want to elaborate very highly on our trace details play. It's coming very soon, but we still use span links in our span links in OpenTelemetry as well.
Yeah, that was a spoiler alert from Vikrant, what we are building on. So, moving on to, I hope this answers your question. Yeah, we have one last question. It looks like a big one. Let me just share my screen for this. So I think it's a combination of multiple questions, and it's around some issues that this person is facing. So rather than like reading the question, the person asking the question, can you just explain or give us more details about what particular thing that you want to get answers for?
I have three queries. One is related to how we can observe or we can trace database queries. Let's say we have MySQL or Redis, Mongo. How can we get a detail of those queries in a particular trace or a span? So that is one point. And another one is let's say we have multiple microservices. In microservices, we have a few of APIs and we have some consumers as well. Like those consumers are listening to any queue. Okay. So how can we get details of those traces? And another one is that if I am searching in a microservice, I am searching for a API, okay, and I am checking for traces of particular API. How I can filter out all of the traces related to single API and how I can browse all of them in a SigNoz UI.
Okay. Vishal, do you want to explain about the database part?
Yes. Yeah. So if you want to trace your database queries, actually, as Doug said initially, OpenTelemetry has auto instrumentation for most of the libraries, of course, most of the frameworks and languages. And just check that. So OpenTelemetry has a OpenTelemetry registry where you can check out the library, whatever library you are using. Is it supported by supported by OpenTelemetry as auto instrumentation? In most cases, from what I have seen, it has support for hundreds of different libraries across the languages. And till now, we have not seen any user specifically for database libraries which are not traced. So even in case of languages where auto instrumentation is not great, like Golang and even C++, so even there, the popular database libraries are supported by default. You just need to add a single line of config so that they are all the DB traces are collected. So I guess sorry.
Those we have tried and those are helpful, but is there any provision that by default all of the traces can be enabled without adding any another library?
Which language and framework are you
we are using like Node.js and Nest.js.
And for DB queries, which library are you using?
For MySQL, we are using SQLize and we are using Redis, Postgres, and Mongoose.
Okay, I as far as I know, Redis, Postgres, and Mongoose, and even MySQL. So in MySQL Lite, I think there are two libraries. The latest one does support it, and all the other things that you mentioned, other libraries that you mentioned, are supported by OpenTelemetry. As far as I know, on top of my head, you can actually check out the OpenTelemetry registry as well. So they would list that. And specifically for Node.js, I will share the doc on, I can say, npm package doc, where they mention if they support the libraries that you mentioned or not. So that's also a good place. Let me just share that doc over chat.
Yeah. Or maybe a couple. If you want, you can just down in your community support channel, right?
Okay.
And tag Vishal and me. And I think Vishal can share over the resources there itself. So it's accessible with
Sure.
With Redis, like you can go to their official docs and they'll generally hook up you with some client. Then that client generally has an instrumentation built in. Like for Go, we use Go Redis, and that comes in coupled with its tracing hook as well. So we use that extensively ourselves as well. I've shared the link to some certain attributes that you can add in that tracing as well. Like it gives you a nice db.statement, db.rows affected, what were the returned rows, and very nicely all of the data is masked. So you get a nice what do you call a templated string that what ran on the DB and how many rows were returned as well. So that becomes very helpful in debugging DB statements and all the DB calls.
Okay. So we have also observed one issue. Okay, so I would like to discuss that. So in our node service, we have made this live in multiple services, but in one service we also have consumers. Okay, those were listening to queue. So after making this, we have observed some issue related to database queries. Okay, so for SQLize, we enabled OpenTelemetry package to trace queries, but issue was that if consumer was running a query, those was executing in loop multiple times after enabling SigNoz. So have you faced such kind of issue?
Have you added retries to your consumers by any chance?
Retries, yeah, retries is there, but in query we saw in single trace. Retries is there, like generally we do not acknowledge the message. We acknowledge only once message is successfully processed by our consumer. Okay, but we observe queries, multiple queries in single trace ID.
So are they part of, like, is the first attempt failing, then that's triggering a retry, and then that is again launching the queries, or what is happening?
No, attempt was not failing.
Okay, without failing in a single.
Right.
You're saying. Seems like an implementation detail couple. We can dig deeper into it in the community channel as well, because I think we do the same as well, and we haven't faced any issue, so we can sit together and we can figure out what might be happening with your system.
Yeah.
Okay.
So Kapil, for the last question, right? I think we are running out of time right now. We are already past our time. So I think the best way would be to just list down all these questions in the community. You can tag me out and Vikrant or someone from the team, right? And we'll try to answer all your questions in the community Slack itself, right? And we'll try to resolve them in the community Slack.
Yeah, sure. I will do that.
Okay, thank you so much. So yeah, I think that was the last question, and yeah, thank you so much, Doug, for this demo, and for everyone who joined in. It was really, I mean, it was really great call. Honestly, I feel really good about this, and you're gonna see, I think, more demos in the coming calls. So yeah, thank you so much for that. Ashu, you want to say something?
No, just thank you for joining in, folks. Thanks, Vishal, Vikrant, and Vibhu for taking your time to join this and answer the questions. And of course, thanks, Doug, for showcasing a great demo. I've already sent you a request on LinkedIn. Let's stay connected.
Oh, cool. Yeah. Thank you so much for letting me talk about observability. It's one of my favorite topics.
Yeah.
Nice meeting you all.
Cool, folks. Have a great day. I'll end this meeting now. Bye-bye.
Okay, bye.